Hello. Today we will solve the irrational equation of such kind. Equation is simple and I recommend you to stop the video, solve it yourself and share with us your answer using the comments. When you return, we will continue to work together. Now you are back and we can continue. As a first step, we will find a domain of the left-hand side of our equation. We see here two square roots, and we know that the radicand should be non-negative. We take first one, 4 minus x is non-negative. The same we do with the second, x plus 6 is non-negative. Here we have a system of two inequalities. We rewrite this system in such form. And finally, we can write the equation for domain. Here it is. We can put these points on the number axis, and domain is the range between them. John has a question. Please. Why do we need a domain? Asks John. In short, we need to know the domain of equation to verify the roots of that equation. We will do this later. And now we will go to the next step in our calculations. Namely, we need to find the root of this equation. How we do this? First, we will square both sides of this equation. As a result, we have the following form of this equation. We distribute multipliers, and we have this equation. Now we need to simplify it. I will write first negative x squared. What is the next term? Please let me know. John tells us negative 2x, exactly. And the last term on the left-hand side is plus 15, the answer from Jan. So we have the following quadratic equation. We change the sign and simplify the writing. Now we need to solve this quadratic equation. At this point, I would like to suggest you a quiz. Given is quadratic equation in general form and three formulas for the roots of this equation. Which formula is correct? John tells us 1, Jen the same answer, and online students also the same answer. So all our students gave the same answer, and this answer is correct. We will use it to calculate the roots of our equation. It is very simple, and please do this yourself and give me the answer. For the first root, online students give us 3, x1 equals 3. Second root, who will tell us Jen gave us negative 5, is okay. And we have the roots of quadratic equation. Actually, we believe that these roots are the roots of our original equation. But we need to verify this. And as a next step, we will do this. First, we will use information about the domain of our equation, which we found previously. Domain is shown here. It is the range between negative 6 and plus 4. Our roots are 3 and negative 5 is here. So both our roots are inside the domain. So they are correct. To double check this conclusion, we will use another method of verifying. Namely, we will use direct substitution of the roots. Here we need to decide in which equation should the roots be substituted, in the second or in the original equation. What do you think about this? The first equation, the first, and John gave us first equation. Great job, guys. Indeed, we need to substitute roots in the original equation. Let's do this. We take first root, substitute to the first equation. We have the following. Here is 1, here is 9, so it is equal 3. On the left-hand side we have 3, on the right-hand side again 3. So first root is correct. We do this with the second root. Now we have here 9, here 1. Again 3 equals 3. And the second root is also correct. Both roots are correct. Now we can write the answer. Do you have any questions? Could you please repeat why do we need to find the domain? To answer your question, we need to return several steps back and consider our original equation, which has a domain from -6 to 4, and the equation which we obtained after transformations. We see that here we have a regular quadratic equation, and this equation has a domain which coincides with entire number line. So x can take any real values. For this reason, the roots of this quadratic equation can be outside the domain of original equation, and those roots will be incorrect. This is the main reason why we need to know domain of original equation. In one phrase, we can say we find the domain because transformation can change the appearance of an equation, but it must never change where the equation is defined. So I believe I answered your question, and now we return to our answer, and we can state that the problem is solved. If you have another solution of this problem, please share it with us, and we will discuss your solution later. And finally, I would like to encourage you to help Dr. B in his work on the future videos. You can do this with likes or dislikes, subscription, or positive or negative comments. Thank you for your help.